Hey Adrian, how's it going? This podcast here is going to show you what I would like the students to do with the mobile lab on the second day of this parallel line investigation. Um, the students know how to get to my website. They should. It should be in their favorites. If not, the link is above the smartboard. Um, Students need to make sure that they have GeoGebra installed on their computer. If they don't, they just need to go to geogebra.org. The link is on my website, so if they can get to my website, they can get to GeoGebra and Dropbox. My home page of my website, if you scroll down, I have important websites here, and it's got GeoGebra and Dropbox, and it has the username password so that the kids can log into the Dropbox account. But they need to go to geogebra.org here, and I just want to show you one thing real quick in the website. Sometimes the install will take a long time. Our tech department and internet are pretty sweet sometimes, but when they get GeoGebra, they click software to install. I would have them do the Windows install, but if it's not their computer that they normally use, if they're getting some other computer, they can just click the Java Web Start. Will be removed in November. I hope this works. I just saw that while I'm talking to you. But hopefully it looks like it's working. Hopefully it'll be working for you. But if that doesn't work, then definitely the Windows install. This is just a quicker. They don't actually download anything. It's just a GeoGebra app that pops up. Okay, so they need to make sure that they have GeoGebra. Then what I would do, I'm just going to cancel this. It looks like it's going to work. Then what they need to do on my website is click on the core geometry link, and on this page, if they scroll down, these are all my GeoGebra files plus a Word document that they need to open as well. But there's 10 GeoGebra files. These are the pictures where they need to investigate the parallel objects. To download them from this website, they need to click these download arrows over here. If they're using Internet Explorer, which I normally use Mozilla, but I'm showing you this in Internet Explorer, they can try to click the download and just do open. And if they do that, depending on the machine, I guess, it might pop up. Mine says enable to launch. If they try to just open the file, it won't pull up GeoGebra. So what they need to do is they need to save the file somewhere that they can easily access it. So using Internet Explorer, if they click that download arrow, next to save is this little arrow here, and if they click that, they can go to save as, and then they can just put it wherever they want. I would recommend for them to put it on their desktop because it'll get wiped out. They just need to have them for the day to do the activity. So they're just going to save it to their desktop like I just did. So they can do that to all 10 of them, or save each one as they work. They also need to download this Word document. So maybe we can open this. So yeah, this for Word works here. A lot of times they'll say I can't do anything on my Word document. They need to see that it's in protected view if they just open it, so they need to enable editing, and now they can go ahead and edit. So they need to put their name here, and I just wrote some notes here. After they investigate each GeoGebra file, there's 10 of them, they need to paste a screenshot. So just to do that, they hit the print screen button on their keyboard, and that'll get a screenshot of their investigation. So they need to paste those on this Word document. Then under each picture, they need to explain, if the objects are parallel or not. And then they need to submit this Word file, not the GeoGebra file. It's just this Word document with their screenshots and explanations. They need to submit this file to Dropbox. And like I wrote in this Word document for you, have them save it as their name. Just, Peter Young or whoever. They can put on their parallel lines if they want, but as long as they save in the Dropbox folder, we can't lose it. So you'll see what I mean. So anyways, let's go ahead and do the activity here. So I'll just show you with the Bandits Field file that I put on my desktop. So let me get GeoGebra running here. So here's GeoGebra. So now we're just going to go File, Open, and find that file that I saved, Bandits Building. It should look like this. If the resolution's a little different on their laptops, it might look a little different, but I try to make it pretty compact, so even resolution problems should not affect what's going on here. So each picture asks, are something parallel? So it gives the kids an idea of what they need to investigate. So I wrote on here the logs. So I don't tell them which logs, because you can see like this face of the building. We could do those logs, we could do these logs, or even these ones. Okay, but they need to investigate if they're parallel. We'd like them to understand that. I got the word traversal. That doesn't sound right to me. I guess it is. But anyways, this other line that we need to gauge to check to see if lines are parallel, I'd like them to get to where they can just use lines already on the building. So, for example, for this, let's check if these logs are parallel here. They could do these logs as well. It's up to them, or these ones. But I'm going to do these side logs here to see if they're parallel. So I'm just going to grab my line tool, and I'm just going to put a line on one of these logs. Okay. I may want it to stand out a little differently, a little brighter or something. And then I'm going to do the same thing for another log. And they only really need to do a pair of two of them. So right now, it's not looking like they're parallel, right? And again, this is the perspective deal here. We know that they actually are, but that's part of the conversation. Still, though, the investigation as far as putting a transversal on and measuring angles, that's really what we want to get them at. But they can see right now that they're not parallel, or we can. Now, I wonder if these ones might be. I'm just kind of doing this as I'm talking to you. Have them be accurate within, I would say, a tenth of a degree. Okay, so I'm going to change these colors because they're two different lines here. So I'm going to make those red. Okay, it might be a good idea to hide. Well, maybe not. Sorry, I'm not going to hide my points. There's just a couple points here, like D and F are kind of not needed. So I'm just going to hide those. So then they can just check, like back to the green lines here. If they didn't put these red ones here, if they just were to investigate these ones, a transversal might be anything. They can just put a line there, but I would use like the side of the building, as a transversal to see if we have a parallel relationship, right? So we can do this, and then they can just measure the angle. I need to put another point on here so I can measure the angle of these lines here. So if we use corresponding, I'd like them to switch up their angle pairs, but at least they're getting an understanding of arguing lines are parallel by looking at, even if they just go corresponding all the time. That's kind of, the easiest ones to look at. But if we just measure these real quick, and they can see, you can also change the color of an angle. Just click on it. In the graphics view up here, we can just change the color to maybe this. So that's 83.14. Measure this angle, 85.7. So we can see not parallel. Okay, corresponding angles aren't congruent, so those lines aren't parallel. Kind of a confirmation. If we try to change this, maybe. C's moving a lot. Never mind, let's not do that. But if we want to check these red ones, I'm going to go ahead and just use this line right here as my transversal to check to see if these two lines are parallel. So since I need the intersection points, so I'm going to grab the intersection points here, and maybe we'll just do alternate exterior. I should have wrote on here, maybe we could specify what angle we want them to measure, but yeah, maybe not. So anyways, let's do this and change that maybe to this green color. It's kind of nice to see on the logs. And then let's check this corresponding angle here. So HP, whatever that is, 97. Now there is some give and take on how we put these lines on. We could make these parallel, or close to it. Like I said too, they can round to the 10th. So these, in my opinion, just because there is a little leeway in how they can put the lines, I would argue that these red ones are parallel. You know, they can get those situated. But this is what I'd like them to do, and they only have to do one set. I just have them do two as I'm talking to you, because I noticed as I'm talking that these weren't parallel, and I thought maybe these are, because perspective shouldn't change these vertical posts here. So once they show this and say, okay, they need to make sure that they use in their reasoning the angle pair names. That's a big part of it, so make sure they know that. But then once they're done, all they do, I'm going to turn off my green shot because they don't have that. Sorry, my computer's slow as I'm doing this. Exit. Okay, so all they need to do is hit print screen, and that's going to take a screenshot, hopefully that worked for me here, of their computer screen, and they're just going to paste that onto their Word document here so we can see what they investigated, and then below they just need to write yes, these are parallel because, you know, blah 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 blah. And then underneath here they just get the next GeoGebra file. So once they're done with this and they pasted their screenshot, they can just go ahead and cancel. They don't need to save it. Open up the next document and do the exact same thing. Okay, now once they're done, they saved the file. They have to do save as, save it as their name. So I'll just do this real quick. So Bowers. Okay, now they need to go to Dropbox again on my website. If they go back to the home screen, at the bottom has the link to Dropbox. This is dropbox.com, but they also have the username and password, so they need to use that to log in. So when they go to Dropbox, this is what it looks like. So they need to enter the username and password. Once they get in there, I don't know why this little window's still up. Once they get in there, this is what it's going to look like. I have the folder here, Core Geometry Parallel Lines Investigation. That's the only folder I have. I deleted all the other ones I used earlier in the year. So when they click on this, they just need to go into their folder, say period 4 or 6, depending on what period it is. And then this is the upload icon. They just need to click upload, choose their file, find out where it's at. Mine was on the desktop, and then they just need to upload it. Okay, so when they do that, where's my Word document? Right here, Bowers. So when they do that, this is what it looks like. And then I'll show you, I don't know if you're familiar with Dropbox. When it's done, they get a little green check mark, and it's right here. Okay, so I'm just going to delete this, but that's what they do. So they're done once they upload their Word document to Dropbox, and then after that, you or I will figure out what to do on grading. Okay, so that will be day 2 of the parallel line investigation. So I hope that made sense. You'll have to work with kids on their GeoGebra skills, you know, measuring angles. We've done it, but the kids are a little hesitant and slow on GeoGebras, so it'll be a little bit of you just going around helping them out with things. But there's a lot of kids too that know what they're doing and enjoy Dropbox. So anyways, give that a shot. I hope that makes sense. If it doesn't, please ask me any questions, man. But I hope that goes well.